The question involves determining the maximum allowable amperage when using number 8 Romex as a tap conductor from number 6 aluminum wiring for a stove circuit, referencing the National Electrical Code, specifically 310.15b16. To determine the maximum amperage and ensure code compliance, several factors need to be considered. Firstly, we must address the ampacity of the number 6 aluminum conductors. According to the National Electrical Code, number 6 aluminum conductors have an ampacity of 40 amps when rated for 75 degrees Celsius, which is 167 degrees Fahrenheit. It is crucial to consult the appropriate ampacity table in the National Electrical Code, which is Table 310.15b16. This table provides ampacity values for various conductor sizes and insulation types, considering temperature ratings. Secondly, understanding the code requirement for tap conductors is important. National Electrical Code Section 240.21 covers the requirements for tap conductors. However, the specific rule cited, 310.15b16, relates to ampacity correction factors and allowable ampacities in general. Tap conductor rules dictate that the tap conductor must have an ampacity of at least 1/3 of the overcurrent device protecting the circuit. In this case, the overcurrent device is likely a 40 amp breaker protecting the number 6 aluminum conductors. Furthermore, tap conductors must have sufficient ampacity for the load served and should not extend beyond a certain length without additional overcurrent protection. Therefore, the number 8 Romex needs to comply with these requirements. Thirdly, the ampacity of the number 8 Romex must be considered. Number 8 copper Romex, with a 75 degrees Celsius rating, typically has an ampacity of 40 amps. However, it is crucial to verify this based on the specific Romex cable being used and the conditions of installation. The National Electrical Code provides ampacity tables for different types of conductors and insulation. Because the number 8 Romex has an ampacity of 40 amps, it technically meets the 1/3 requirement, as 1/3 of 40 amps is approximately 13.33 amps, and 40 amps exceeds that value. Fourthly, the termination and connection methods need to be addressed. When connecting the number 8 Romex to the number 6 aluminum conductors, it is essential to use listed and approved connectors that are suitable for connecting copper to aluminum. These connectors are designed to prevent galvanic corrosion, which can occur when dissimilar metals are directly connected. Antioxidant compounds should be used when terminating aluminum conductors. Wire nuts, splicing devices, or terminal blocks used for this purpose must be rated for both copper and aluminum conductors and must be properly installed according to the manufacturer's instructions. Fifthly, the overcurrent protection requirements must be followed. Even though the number 8 Romex has an ampacity of 40 amps, it must be protected by an overcurrent device, such as a circuit breaker or fuse, that is rated no higher than its ampacity. This means that the circuit breaker protecting the number 6 aluminum conductors, which is likely a 40 amp breaker, also provides the necessary protection for the number 8 Romex. The overcurrent device protects the conductors from overloads and short circuits. Sixthly, consider the National Electrical Code requirements for electric ranges and cooking appliances. Electric ranges and cooking appliances have specific requirements outlined in Article 220 of the National Electrical Code. These requirements address the calculation of the load for the range, the minimum branch circuit rating, and the type of wiring methods permitted. In many cases, a 40 amp circuit is sufficient for an electric range, but it is crucial to perform a load calculation to ensure that the circuit is adequately sized. The National Electrical Code provides guidelines for calculating the demand load for electric ranges, taking into account the range's nameplate rating and the number of cooking elements. Seventhly, dating factors must be considered. If the conductors are installed in an environment where the ambient temperature is higher than 30 degrees Celsius, or if there are more than 3 current-carrying conductors in a raceway or cable, dating factors must be applied to the ampacity of the conductors. Dating factors reduce the allowable ampacity of the conductors to prevent them from overheating. It is crucial to consult the National Electrical Code tables for the appropriate dating factors based on the specific conditions of installation. Eighthly, local amendments in regulations should be checked. Local jurisdictions may have amendments to the National Electrical Code or additional regulations apply to electrical installations. It is essential to check with the local building department or electrical inspector to ensure compliance with all applicable codes and regulations. This can help avoid potential violations and ensure the safety of the installation. Ninthly, consider voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to operate inefficiently or malfunction. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to use larger conductors or reduce the length of the circuit. The length of the run needs to be considered in this context. Tenthly, documentation and labeling is important. It is always a good practice to document the electrical installation and label the circuit breaker panel to clearly identify the circuits and their corresponding loads. This can help with troubleshooting and maintenance in the future. The labeling should include the circuit number, the amperage rating of the circuit breaker, and the load served by the circuit. In summary, using number 8 Romex tapped from number 6 aluminum for a stove circuit is possible, provided that the number 8 Romex has an ampacity of 40 amps. The connections are made with listed and approved connectors, the overcurrent protection is adequate, the load calculation for the range is performed, and all applicable National Electrical Code requirements and local regulations are followed. Remember to consult the National Electrical Code and local authorities for specific requirements and to ensure compliance. Improper installation can lead to electrical hazards and code violations.